Hello, and here's our lecture of our digital forensic. And then today we will move on talk about some nice techniques for like hiding and scrambling information. So will be the stenography or some encryption. So we will explain some like techniques for hiding and scrambling the information. So that how the data is recovered. So that's we try to do. And then the steganography and the encryption. So we're going to learn. So for the steganography, it's actually kind of the art and science, like writing some hidden message. So if you look at the content, just imagine if an image. So if you change like some bit, okay. So you until you really look at those hidden information. So even like that they are like intercept and then it's not clear the information is hidden there. So if you look at sometimes maybe we use example, if you have the JPG image file, we look at the color bit, but if we change the bit pattern a little bit, like change the color, so it will hiding certain message in the JPEG file, PNG file, image file that we can do. So the most common method we hide a message is in the picture we say the least significant bit LSB method. So that's what we know. And then as well as taking as an example LSB method. So we consider if we have the right here we have complete bit, right? So we have total UAC we have 8 bit. If we change the last bit to 0, so we're in decimal number the first 7 bit and last 0 keep it. Okay, so we have like 254 in decimal, and then the last bit or the least significant bit LSB can be used for store data. Okay, and those like color pixel in the computer store, they're in bits. So here's the idea: like if we have the LS, so we save in the bit method. So when we're picking different bit, and when we change a little bit, like let's say the RGB, okay, so the color change all the numbers, and they can change. So they are all possible, but of course, like in the lab, later in our lab, we try to do it. Okay, so you have a better idea. So well now, if you need to consider because all those like all the color save as a bit. Sometimes you see they're in hex, sometimes but if we convert they're all in a bit pattern. Then even we change the number, hiding the color. Okay, so for the like basic steganography terms, including the payload, carrier, and channel. Payload, that means the content carrier who listen it and through what kind of channel. So we can see. And under then some like slightly history. So for the Asian like Chinese wrapping note, so they're in the wax, right? So they swarm them and then for transport. Okay. And then in Asian like Greece, they try to some message, they wait on a slave like shave the hand and then their hair allow them to let go back. So they would confide. So here's the same idea. And maybe the World War II, so French resistance like send a message. So the reading on the back of the courier is like using invisible ink. So they all this like possible. That means they want to hide the original format. And in other format like the phony and then video or like advanced. So they try to maybe like phone will be like hide the message in the sound file. So when you open the audio like regularly play it, you didn't hear the really change. But when you try to isolate certain of it, then you can able to find. And then video, so they will hide it in video because when we have a picture, you know, maybe within 1 second, how many 12, 40 frames. So video can be also possible. You just end that format, make some like bit plan complexity segmentation for the steganography, so it's a BBCS. And how can we do the analysis? So this one to analyze a file or some files for hidden content. So we try to show like likelihood. So we give them file, they have additional information. So what those are information hidden inside. And most of the time we like put common method and we'll do just detecting the LSB like to check the close like color pairs. Okay, so this we're going to do. Right here is one of the software application tools we can use. It called invisible secret. Okay, so here's one. So if you want to encrypt or hide the file, the keyword, if you remember the keyword, we have the payload keyword and then channel. So this one, like, what kind of a keyword? Okay, so maybe we have the image. Okay, how can we encrypt it next? And then we can choose the image. Okay, which image we're going to use. And after we choose the image, and then we can like go ahead. So we maybe like choosing one before hidden. Okay, and maybe we can set some specific password to encrypt it. So to access, so we put a password and move on to the next step. So we will try to giving like it will try to doing some target file settings. We're going to do like set it, and then after we complete, so we start the encryption. So the encryption of the obfuscate the message so it cannot be read, and also the cryptography also is the study like writing the secret message. So one under the like cryptography will be the encryption, decryption, like with something. If you learn in cybersecurity, will like symmetric, so they're kind of it. And then the words like cryptography will be like delivered from the word like this. So they're kind of like hidden. Okay. So like hidden and white. Okay. And between the encryption and graphic will be including the for this one, if you want to like hide the message, so it belongs to a graphic. Okay. But if you want to let the message present, but under the obfuscate, that means we try to encrypt it, we cannot read it. That understood that is under category encryption of cryptography. Okay, so here's the differences between them. And then for the CSCI cipher, so this one of the method we use like for the encryption. So it kind of like the substitute cipher. So it's a really simple method we use for the encryption. So just really need to like record what you learn in your cybersecurity. We touch about it. So we just choose a number, random number. So we like for shift each letter of the text. So we like if you remember change it shape, and then we substitute need the alphabet letter for the letter being encrypted. And if we try to like have an original text like a cat, and then if we like shift the two letter, so maybe like A represents do like this, then when we read it horizontally, then it will change to the CEA. Okay, so we change that by three by three letters will be changing D and space FDW. Okay, and depends. Sometimes we handle the special case or something. No, so if you be some student taking my class, you remember we have the online tool. So I say, okay, you need to guess how many what's the number of shift like this. So you can guess. And the mechanics is pretty straightforward. We say easy, but you need to take some time to change it. But right now, once we have the program, it's pretty straightforward. We can get a result. So we like two key terms. One is like called a plain text. The text we want to encrypt is called plain text. And after we pass through the algorithm and key, we call the ciphertext. So here's the two keywords, and even to all other encryption method, plain text to ciphertext, ciphertext to decrypt it to a plain text. That's all the keywords. Average cipher, so it's a reverse the alphabet. So it tried to substitute the like first letter of the alphabet for the last letter, and the second one is for the second last, so on and so forth. So keep going. So it's a primitive and also easy to break. And we have about 13 cipher, so it's the permutation of the CSCI cipher. So all the character, they will rotate 13 characters through the alphabet. Okay, so if a cat, they will 13 them N and P and G like this. Sign tails and the cipher is an encrypt message to wrapping a leather strip around the cylinder or pattern, so they're reading across the leather. Okay, by turning the cylinder, say produce different ciphertext. So it looks like, so this message is like decrypted by reading the message once paste on over the same letter key. Okay, wrapping around the same size or cylinder. So it's the idea. And then we have one more called the pay fair. So pay fair will be like encoding pair of the letters. So they also called digraph. And then at a time, so we use the maybe 5x5 table. So it can contains a keyword or a key phrase. So when we try to use the called pay fair cipher, then we need to use the to memorize the keyword and then the for loops. So like attack and then AT and then break and then like this. So we need to like follow the rules like 5x5 to change it. And when you're putting like here, just keeping the like when you're putting the 5x5, and then we try to match it, and then ALE, and then BJ right here. So keep down LDK like this. And then we have the like called the multi-alphabet like substitution. So we can use like multiple numbers. So which can be like let the letters in the plain text shift, and then multiple substitution alphabets they can be created, and then they will present some nice like improvement on the CSCI cipher, but it can be also easily cracked. So right here you will see we introduce like different type and pretty straightforward. So if you may see like select like three substitution alphabet like +2, -2, +3, so you can change it like this. Okay, +2, and then -2, and then +3. Okay, and then +2, and then it will like this. This is multi. Okay, and this one, Winjuni cipher. So this one will be matching like 8 to 8. I think this one also is one of the example we go through show before. So we just like match it with it like L, and then match it to which one maybe M, N, and then we'll change the new one. Enzyme machine. So in World War II, we have electronic mechanical like rotor based on cipher system. So it's also the multi-alphabet substitution cipher. So for this example, using the machinery to establish the encryption. So when the operator press a key, then the encrypted cipher text from the plain text will be altered each time. So this is how it looks like. And we also have a modern cryptography. So mainly have a symmetric and asymmetric. So that's more like closer what we learn nowadays. For symmetric cryptography, we use the same key to encrypt and decrypt the plain text. And asymmetric, we use a different key to encrypt and decrypt. So we use the public key and private key. So that's what we learn. And we use the everyday minimum consumer like World Wide to buy the products surface. If I want to know more like IoT stuff, smart things, so it's increased a lot. So we right now like HTTPS right here we be dealing with the web address or like the padlock symbol to indicate the secure protocol. So you're using a transport layer security, so TLS. Sometimes you see the TLS SSL, so it's a complete name. So like this. And also the cryptography we're using for antivirus software, and also the wireless security WPA, WPA2. Right now we have like 3, and then sometimes with the max, so put that a lot. And also the hard disk encryption. So maybe we have the like Microsoft encryption file system. So it's one of it, even like Apple, it also have an encryption of the file. So put that a lot. And even the like the mobile phone transmission can be like encrypted, also like MTK or like credit card, AMT, those things. So being like this. And for the symmetric cryptography, so we use the same keyword, just like repeating. So all you are pretty familiar with it. And we can use two different encryption keys from the sender and also to the receiver, and one from the receiver to the sender. But the same key is still like used for encryption and decryption. Okay, so we can use a different key, but they have to like in both directions So they will provide additional security if the key are learned and decode. So it's like his idea. And we have some like substitution and transposition. So maybe we will swap the blocks or ciphertext. So right now, all our like modern block cipher algorithm, we will use the substitution and transposition. By combining all these like substitution and transposition, so we can increase the security of like resultant ciphertext, make it the ciphertext analysis more like complex. You see that even we introduce like symmetric or asymmetric, you see we still have some easy to expose the our content. Then we try to like increase the like combine different methods, like maybe mainly is the substitution and transposition to make the content more like complex encryption. And for the block cipher and then the stream cipher, so we try to like encrypt the data in the groups of bits. So as long as I call a block, and also if we are encrypt the data, so as a stream, like 1 bit at a time, so we call it a stream cipher. So we have 2 different cipher types. So we know. Well, physical function, so including if we have a block cipher, we say like from the plain text, so we will like getting like half the block, okay, and then maybe we give a run function f, and then maybe output the f, and then we using XOR. XOR will be taking maybe another block out, and then using the XOR to match, then we output the XOR of the output of f and r. So like this. So it's one of the method, and then the data encryption standard, including like we will try to divide the data into 64-bit block. Okay, so those data can be like manipulated by 16 separate steps. Okay, so if you that is a DES, so we going like go through the like substitution, bit shifting, and then have a logical operation. So using a 56 bit key. So here's the step. So and then we will follow the like scramble means in using a swapping algorithm. So they will like transpose once at last time. So these are steps. Here is will be the exam. I think I did show this one before, so but didn't really go into details. So you see we have all the steps, including like we do the substitution and then do the bit shifting and then some operation, logical operation, and then do the substitution, bit shifting. So we are repeating like 16 times. Okay, but also it's possible to trace back. So we add one more like duplicated to 2 times the DS, and but it wasn't that much secure than DS, but it took more time and career resources to implement. So that's why not widely used. Here's the reason, because if you even take 2 times, if you just doing reverse engineering and trace back, like reverse all the steps, so it doesn't means anything. Like even I make it to 2 times, 3 times, it means nothing, but it just take more time to implement. Okay, so that means it more. And then later we create like it's called a triple DS, like 3DS. So it creates like in terms the solution to DS. Even so, it does the DS 3 times with 3 different keys. So repeated, so it make it more complex. And then how about we say 4 DS, like quote one. Okay, so we never, because like in the early simulation indicate it was like 2 scramble. Okay, so all the like block or regional flags appear in the final ciphertext, and also once like driving factor behind searching a new algorithm, so not in the DS line. So this like what it looks like. And next one is called the advanced encryption standard, AES. So it's a rigid block cipher. So we will have different type of encryption, including the key size 128, 192, 256. So sometimes you see the AES 128, AES 192, and AES 256. That's how it looks like. So for the step we're taking, First, we have the key expansion, and then we start our initial run adding the run key, and then for the runs, we will like substitute the byte and then shift every row and max the column, and then we add the key. So we just like keep doing this, repeating, and go to the last final run, and we substitute the byte and shift the row and add the run key, and that's it. So we are not mix the column anymore. And we have the like the cryptographic hash. So hashing is one of the cryptographic algorithm we use for some specific characteristics. So it's one way, so it's not reversible. So it has a fixed length output. So no matter what the input is given, so but it must be collision resistant. So we need to be careful. It's kind of like because the pigeonhole principle. So because we have for hashing, like it may be we have like same output, then we need to avoid those like same outputs. Then we need to have a collision resistant. And for the asymmetric cryptography, so we try to use the two keys, right? So one encrypt the message, one is to decrypt it. So the RSA we're going to use, so it kind of described in 1977. And right now we are using it for variety, so using a public key cryptographic algorithm nowadays also is based on the relation of a prime number. So if you remember we have a two key and then try to get their prime number. And right here, because in this class we don't have to like you to do the calculation anymore, so you just need to have an idea, or I will prepare next time so you can just help you to recall the memory how how it works. Okay, so the security of the RSA is still like difference like from the factor. It's still difficult to a factor like large integer composed maybe two or more like large prime factors. How it develop like Hammond will be the cryptographic protocol. So they will allow like two parties establish a shared key. So over an insecure channel. So they will like that. So maybe it can be like used to allow the parties to exchange a symmetric key. So through some insecure media like through the internet. So it's actually it's happening before we use lecturing the key. So we enable all the secure communication between the parties, or we do not have a pre-established relationship, like let's say e-commerce. So it's how it works. And we have the groundbreaking research provided like foundation for the secure transaction across the internet. And also the e-commerce side right now we say right here. So they will provide some like secure electronic communication. So they are part of it based on this one. And for the breaking and encryption, so it will increase the cryptanalysis. So it will be using the techniques. So other than like just brute force to attempt uncover a key. So we will like refer to some academic or some knowledge-based code breaking. Also, it also may be used to like test the efficiency of the cryptographic algorithm. So we can test it, the hash for the collision, and also the frequency analysis. So right now in our natural language, so maybe for certain letters of alphabet appear more frequent than others. So we by examining those like frequency, so we can like deal with like some information about the key use, and also some methods like effective against the classic cipher. But it's not modern method of the cryptography, so it also can be used for the frequency analysis. Kasky, okay. So this one is the method attacking the polyalphabetic like substitution cipher, and also it can be used to deduce the length of the keyword used in the polyalphabetic substitution. So it's the one method. So it works like when the length of the keyword is discovered, so the ciphertext will line up like maybe in n column, and this will be the keyword's length. And then in each column, they treat as like model alphabetic substitution cipher. So it can be like quite by using the frequency analysis. So that we're checking like which one comes more frequency. So it involves some looking some repeated string in the ciphertext. So can be checking. So right now we'll be so far quickly go through all those modern methods we know. So what's those plain text, and then we have chosen plain text test, ciphertext only, and also some like relate key attack. So there are possible way to doing the in the modern way, and there's another application of a crack. Okay, so it's called a rainbow table, and it will show the example. We're doing something similar, and then join the repair. So it will be the password cracker that probably using for network administrator and hacker. So it can allow user to stack a test file of a work. So this then attempt to create a password. So it's a command line based interface that we can use and to create a password. And however later we can try to go through try it. So here we will quickly go through some basic information like about the two types of the what we go through like steganography and also the encryption. To have like also introduce pretty a lot of encryption, and actually this encryption will become like overlap what we learned before in the cybersecurity. And more practice, you need to have some ideas, some keywords. But if we do have extra time, I would like to cover in the lab, then show you more, like help you to recall the memory how those encryption work. Okay, and that's it for this class. Thank you.